Okay, so let's solve the questions given in the weekly contest 490. So find the score difference in a game. So you are given an integer array nums where nums of I represent the point scored in the ith game. Okay, and there are exactly two players, and initially the first player is active and the second player is inactive. And the following rules apply sequentially for each game I. If nums of I is odd, the active and the inactive players swap the roles. Okay, suppose if the number is odd, the active and the first, if first is active, so it will become inactive, and if second was inactive, it will become active. And in every sixth game, like 5, 11, 17 indices, the active and the inactive players swap their roles. Okay, and the active player plays the ith game and gains nums of I points. Okay, whoever the plays the ith game, it gains the points at that particular index. So return the score difference. Okay, so and that finally we have to return the score difference of both the players. So let's try to code this. Let's first create the player class. So let's create a player class. We can put it as class player, define the constructor. It can take the input as first, of course, the self, and second let's take input as is active or not. So we can mark initially everyone self dot is active is equal to whatever input we has given is active. Okay, and define one more variable self dot score for related to each player, which initially it is 0. Now let's try to code this. So let's define our player 1, and player 1 will be the object of the player class, and currently it is saying that the first player is active, so we will mark it as true. Similarly, we will go to the player 2, and it will also be the object of the player class, and initially it is marked false, so let's mark it false. So player 1 is equal to player 2, and this is false. Now let's simply go through this num. So for I comma value in enumerate nums. Okay, suppose if we have to check in which cases this values get swapped. So if value modulus 2 is equal to 0, if value modulus 2 is not equal to 0 means it's not even, means it's odd, so we can simply swap it. So player 1 dot is active, so we have to just reverse. If it was true, then it will be false. If it is false, then it will be true. So that we can simply do by this. Player 1 dot is active, this will swap from true to false and false to true. Similarly, we can do for the player 2. Player 2 dot is active is equal to not player 2 dot is active. Okay, and what is the other case when it will be swapped? If the index is either in this 5, 11, 17, 5, 11, 17, and if index is 5 odd, you can define it as modulus 6, I plus 1 modulus 6. So if I plus 1 modulus 6 equal to 0, modulus 1 modulus 6 is equal to, then also we will return this same thing. And then also the sign will change, and if both satisfied, then sign will not change. Okay, now what we have to do is we will check if whichever the player is active, the point will be added to that particular player. So if player 1 dot is active is equal to true. Suppose if player 1 is equal to active is equal to true, then we can simply add player 1 dot, we have defined this score variable for each at the class level only, so each object has that score. So you simply plus add the value. If player 1 is active, if it is not true means other one is active, so simply player 2 dot score plus is equal to val, and finally we can return player 1 dot score minus player 2 dot score. Let's try to run and check. Okay, some typo mistake here. Player 2 dot score. Let's try to run and check now. Okay, so first was 0 0, then second is 4, and it's 4, and the third one is -1, and it's -1. Now try to submit and check if this works. Yeah, so our code has passed successfully. Let's go to the next question. Okay, so our next question is take Digitorial permutation. So we have given an integer n, okay, and a number is called Digitorial if the sum of the factorials of its digits is equal to the number itself, okay. So for example, the number is 145, then 145 should be equal to 1 factorial plus 4 factorial plus 5 factorial. So factorial is nothing but the multiplication till 0, like 4 factorial will be 4 into 3 into 2 into 1 into 0 factorial, and 0 factorial is nothing but 1. So that how it's work. 4 factorial will be 24. And what we have to add, determine whether any permutation of n including the original order forms a Digitorial number, and we have to return true if such a permutation exists, otherwise false. And the factorial of a non-negative number x denoted as x is the product. Yeah, what we define the factorial definition. A permutation is a rearrangement of the digits that does not start with 0. Yeah, okay, so 145 can be written as 415 or 541. Okay, yeah, or 451. So all this will work. So now let's try to code this. Let's first import the counter variable, which will help us to keep the count on collections. You can simply import counter. Okay, and let's define here real, and always it's good to take the copy of the given variable, not using the original one. Now the only possible digits, okay, till for this particular range, the only possible numbers whose sum is equal to the actual number, whose permutation sums are equal to, are only few, and those are, let's define that in this variable. So those are only 1 2 145 and 40585. These are the only numbers which are possible, okay, whose sums are sums are equal to that. Sums are equal to their sum of their factorial. So now define the target variable. It will be the counter of nothing but the str. How it will be the counter of the elements in this given input. How many elements, how many digits are there, like how many times 1 is there, how many times 4 is there, all this. And now simply go in digits. Only we have to go, only we go 4 times, okay, as we only know only this can exist whose factorials are equal to the, whose factorial sum is equal to the number. So for num int easy, you can simply go if will match if counter of str of num, okay, if this is same as the target which we have defined. Means we have got our value, and we can simply return true, or after checking for the all the digits, if we didn't get anything, we can simply return false. Now try to run this, check. So for first one is true, for the second one is false, okay. Now try to submit and check whether this works. Yeah, so the code has worked successfully. Now let's move on to the next question. Okay, so this question is, you are given two binary string s and t, each of length n, okay. You may rearrange the characters of t in any order, but s must remains unchanged. But s must remains, okay, we don't have to change the s, but we can just use the permutation of the different t. And what we have to get, finally return a binary string of length n representing the maximum number value obtainable by taking the bitwise XOR of s and t. Okay, what will be the maximum XOR of getting s and t? So we know that the XOR property is like, if both the numbers are same, it returns, if both the numbers are different, it returns 1, and if both are same, then it returns 0. For example, suppose if you do the XOR of 1 and we do the job of 1 and 0, so it will give 0. If we do the job of 0 and 1, it will give 1. Sorry, this type of missing 1. If both are different, it will give 1. And suppose if it is same, 1s or 1, it will give 0. And similar for the zeros or 0, zeros or 0, it will give 0. So we have to try to make such a permutation that uh, the magic index, suppose at 0 it's 1, so either here should be 0, so that both are different and we can get the maximum sort possible. So let's try to code this similarly like other question, like import counter. So from collections simply import counter. So let's count how many bits are there for 1 and zeros in this t1. So count is equal to counter of t, and we can simply take a result variable, okay, to store the bits after this changing this t. Now go through the s for bit in s. Let's define opposite, okay. Opposite is equal to 1 if bit is equal to 0. If it is 0, we have to take 1, okay. Else if it is 1, we have to take 0 to maximize this, or we are doing this. Now suppose if count of opposite is greater than 0, that means we can take this value and means put it like, if suppose we have 0 in the count, okay, so we can simply place it at the top to counter this 1. If it is 1, so we should put 0 here to maximize the job. So we can simply append that in the result that append opposite, okay, resultant opposite, and count of opposite will decrease by 1 is equal to 1, okay. And suppose if we don't have that opposite one in that particular t, okay, so we can't do anything, we have to simply go with the bit only. So result dot append bit, and count of bit will decrease, count of bit will decrease, so minus is equal to 1. So we have got our answer, just we have to simply concatenate it or take its integers and do the job. So let's get this answer. Now go through the loop for a comma b in zip of s comma result. It will go each indexes at once, and it is given that size of both s and t are equal, so no worries, we can do that. So simply answer plus is equal to str. We have to finally return a string only, so do the str of, for zor we have to convert that to the integer, int of a or int of b, int of zor, int of b, and simply return answer. Now let's try to run and check if this works. Invalid syntax. Opposite is equal to 1. What we have defined here for bit in s, opposite is equal to 1 if bit is equal to 0. Opposite for bit in s, opposite is equal to 1 in, oh sorry, in place of if we have written in here. Now try to run. Okay, so first answer is 110, second is 1101, third is 4 times 1. Okay, now try to submit and check if this works for all test cases. Yeah, so this also passed. Let's move to our next last question. This is seems to be hard marks question, so let's try to do this. So you are given an integer array nums and an integer k. Start with the initial value is equal to 1 and process nums from left to right. Okay, at index you must use exactly one of the following operation. Okay, either we can multiply or divide or leave nothing to. So after pre-processing all elements, value is considered equal to x only if its fractional value equals to the x. See, it's not telling decimal value, it's telling fractional values should be equal to x, like 2 by 3, 1 by 2, all this stuff. So return the count of distinct sequence of choices that results finally where. value which is equal to k. So divisor, so here it is mentioned division is rational exact, not integer division. So 2 by 4 is 1 by 2 rational. So let's make use of Python fraction module to keep exact fraction so that answer does not get mixed match if we use the decimals. So from fractions we can simply import fraction. We will okay, and in this type of question generally we have at this step where we can do multiple things. We generally use DP with memoization. So for memoization we can use LRU cache. So let's do that. So from tools import LRU cache. Okay, so let's try to code this now. Let's take a variable new num is equal to num. Okay, let's the copy of that, then we can take the length of it and num is equal to new num. Now let's define, finally we have to get this value, right? K is k. So first let's convert this into the fraction, like k by 1. Numerator will be k, denominator will be 1. Just convert it into yeah, rational. So let's target is equal to fraction of key and 1. Okay, now let's define our DFS function. So first of all, what we will be calling? We will be calling a return. We will be passing out, we're calling the DFS function of course, while passing the index 0 first. Numerator will be 1, denominator will be 1. We are passing this numerator and denominator of the value. Still now that we have to start with the value 1. So let's pass here 0, where we can take here comment like first one is index, second is numerator, and third is denominator. Okay, so now let's try to create this DFS function. So define DFS, and what all things we will pass: index, then numerator, comma, denominator, numerator, comma, denominator. Now let's try to code this. So for again current, first convert the current one into the fraction, as we want to compare the fractions, not the decimals, decimal numbers. So fraction of numerator, comma, denominator. Okay, numerator, so it will be 1 by 1 for current 0 index. It will be 1 by 1. Now suppose we have reached at the end, the best cases of our recursive call. So we will simply return 1 if current is equal to target. Current is equal to target. It should match this. We have converted the k into the target with the fraction like it's 6, then it is 6 by 1. Else we can return it as 0. Now let's define first total is equal to 0. Let's the total sequences are 0. So first let's do this multiplication task. Multiply, the first thing they said, now we can multiply value by nums of I. Then do that. Multiply is equal to current into new num of I. Okay, multiply is equal to current into new num of I. Then you can simply add it. Total plus is equal to DFS of, go to the one index further and multiply both numerator and denominator by this. We have multiplied here now both numerator and denominator with the new num of I. Not both multiply and numerator, like we will always try to keep this as a rational. Okay, we will not go into the integer divisions or integer multiplication. So let's pass out this. There is a function called numerator which will give you the numerator of this value. So just pass them as we are taking a numerator. Then you can similarly you can pass out the denominator. Okay, and similarly you can go again for division. Now for the division, what we will do, simply division is equal to current divided by new num of I. Okay, and again we will add this. Total plus is equal to DFS of, go, we will go one index further, I plus 1. Then again we will pass the numerator of after the result. Then after the division dot numerator. Similarly we will pass division dot denominator, so denominator, and last no change, skip. Okay, and last one is skip. So what you can do, simply total plus is equal to total plus is equal to dfs of you will go to index plus 1 I plus 1 and numerator and denominator will be same, no changes. Numerator and denominator will be same, and finally we can return total. So if we try to run this and check this works. Okay, name num is not defined, it's nums actually. Let's try to run and check now. Okay, so first answer is 2 correct, the second one is also 2 correct, and third one is 3, so also correct. So it will pass, but it will give TLE. So for that, now we have used the recursive, we have to use the memoization. For memoization only we have imported this LRU cache, so simply add it at the top of your function. So I defined LRU cache, and you can pass as none. Okay, now I hope this will work. Let's run it and let's try to submit it now and check. Yeah, so our code has passed successfully. We have solved all the 4 questions. Thank you for watching.